My name is Chris, and this is my video for the final project for fluids. Here we've got the workbench. I've already done all of the cases for the project here, and we're going to go ahead and demonstrate a 10 meters per second version. So first we'll bring over the fluent. Let's name this example. Okay, and then we're going to open up the design modeler here and draw our wind tunnel. Okay, so first thing we want to do is zoom in a little bit so that we have more along the lines here of our dimensions. And now we're going to draw 3 lines. 1, 2, 3, and let's define these. Okay, this is going to be 1.1175. This one's going to be 1.2192. And this is going to be 1.5748 meters. Okay, now that we have these, we're going to draw one big line over top so that we can center it at the origin. Okay, and then make the constraints here the midpoint, this big line. Okay, so we've got the line centered at the origin here. Okay, and then next thing we're going to do is draw some vertical lines. Okay, we need 4 of them, so we're going to draw 4 here real quick. Okay, now we'll set the dimensions. Alright, V4 is going to be 1.6256. Okay, this one's going to be 0.6096. And so is this one. And this one's going to be 0.89. Okay, now we will put them on our wind tunnel. There we go. Looking pretty good so far. Okay, so we've got the skeleton of the wind tunnel here. Now we're gonna connect the lines. Okay. Alright, so we've got the basic shape here. Now let's trim it up a bit. You can do that by going to Modify and using the Trim tool. So basically you just want to trim out all the internal lines. It's going to delete some of these dimensions, but we've already defined them and the lines aren't going to change sizes. So the next thing we're going to do here is, now that we have the basic shape, we're going to go ahead and make a copy of this real quick. Okay, so we've got the copy. This is so that when we go back to do the cylinder version of it, we can just draw the cylinder real quick instead of redrawing that whole thing. Alright, now the next thing we're going to do here is go ahead and do some surface from sketches. Box select everything, apply, and generate. So we've got our surface. Now we should be good. Okay, so we got the green check mark. Now we're going to go to the meshing. So let's close this out. meshing here. First, we're going to have to name all of the walls. Okay, let's wait for it to come up. Okay, so we've got this surface here. Now let's go ahead and name everything. So go to edge select, select this and call it velocity inlet. Okay, and we'll select all the outer walls by holding control. Should be 6 of them, and you can tell by looking down here. Press N and then just call them walls. Okay, now we're going to select the outer part, call this outlet. Alright, now we're going to click on mesh here, and then we're going to go ahead and click on that, apply it to the surface, and then make it triangles. Now we can generate that. You can be able to see a simple mesh here. Now we need to change the sizing a bit. So we click on the face, apply. Now we're going to go ahead and change the element size to 0.005 was pretty good. Okay, now we're going to generate. And this is going to take a little bit of time. Okay, now we'll click on mesh and then we can zoom in and see a very fine triangular mesh. It's looking pretty good. Now we can close this out and go on to the next part. Make sure we update this. Update. This generally takes a little bit of time as well. Okay, we've got the check mark. Next we're going to go into setup and double precision just to make it go faster. We can take advantage of our hardware. Go ahead and start that up. Okay. We've got our surface. Now we got to change a few things. In some of the other tutorials they were turning energy on. I'm going to do that as well. Change this to K epsilon to equations. Make this enhanced wall treatment, pressure gradient, and thermal effects. Now we're going to be okay here. So then we press OK, and then the next thing we're going to do here is go onto the materials. We're going to click on air. Now for the hold on. So for the viscosity here, we need to make it Sutherland viscosity. That's what it says to do in the rubric here. So it says 2 coefficient Sutherland viscosity, so that's what we have here. And then we'll press OK. And it also says use air as an ideal gas, so this is where we change this to ideal gas here. Okay, got the Sutherland. Now we can change create and close. Next thing here, we're going to go into the velocity inlet. And we're going to change this to 10 meters per second. Okay, and we apply that, close. Alright, and then we're going to make sure that the walls are stationary, no slip. Okay, we're good. Next thing here, we're going to go to reference values, compute from the velocity inlet. The other tutorials were saying to change this to 27,000. And now you can see our density is going to be a bit changed there. That's because we uh, defined it as an ideal gas. Reference zone, surface body. Okay, and then next thing here, we're going to just make sure that the methods are good. Okay. Got coupled, we've got second order upwind for the momentum. Okay, so we should be good there. Now we're going to initialize. Okay, now that we have the initialization, we can run the calculations, and hopefully that'll be enough for it to converge. Okay, so we converged after 39, which is pretty short there. That's okay. Alright, so now we're going to look at some of the results here. We'll do it all in this setup. We'll do most of it here. You can look at the contours here. So first we'll check out the static pressure. Click on all these guys and display it. Alright, looks pretty good. Next thing we're going to do here is the total pressure. Okay. Alright, looks pretty good, pretty constant. Next thing here, dynamic pressure. We can look at this one. We'll make a new one. Dynamic, click everything, and then save display. Okay, looks pretty good there. Alright, and then last but not least, the velocity. Velocity magnitude, save display. Alright, looks good there. Okay. Now, the other thing that they wanted us to look at was the some of the XY plots. So, now, for the next part here, okay, we're gonna look at the XY plots, but we're gonna need to create a center line here. So at the center line, we're gonna make the x's are going to be 0, and since the center line was going to be on the x-axis, and then the y values here are going to be 2 seconds. Okay, we'll make the y, I'm sorry, the y values are going to be 0, the x values are going to be 1.95575, and this one's going to be 1.95575. So this one's negative because it's going all the way back this way. The origin's going to be right about here. And then this one's going to be positive because it's going this way. So then we'll call this center line. Okay. Create. Oops. created two of them. That's okay. Um, Now, the next part here is we'll just name this plot the static center line. And then okay, now we can go ahead and plot it and look at it. Alright, so it looks pretty good, about what we'd expect. And then the next one here that they wanted us to look for was the total pressure. Okay. Total pressure, click the center line. We made that one and it'll stay, which is good. Now we can look at this. This is going to be a little bit jagged here. Usually what you want to do is write this to file, save it, and then upload that data onto an Excel file, and then you can just plot it. And you'll be able to zoom out. You can actually zoom out here. If you click on axes, and then if you zoom out a bit, it'll be, you want this to be like 197, and then this to be like 200. If you apply it, whoops. Oh, this is x-axis, so we want to change the y-axis actually. Okay, and so then if we apply this here, auto range, apply. Okay, so now you can zoom out here in Fluent, and it'll look more like a constant line, which is what we're going for. Can actually show you my results here. This is what it should look like for when you plot it in Excel. It'll just be constant, like one line. Okay, and then next thing here, we're going to look at the dynamic pressure. So let's close this here, make a new one. This will be dynamic, center line, save and plot. Okay, so that's the dynamic. Looks pretty good. The next thing here, we'll look at the velocity, magnitude. Okay, so we gotta change this to velocity, velocity magnitude, center line. Okay, and so this is going to be the velocity along the center line, about what we expect. In the convergence chamber, it's a bit slower, and then it gets faster into the test section, and then slows down in the diffuser. Alright, now the next part here is going to be just looking at the vertical distributions of the different pressures in the test section. So in the test sections here, we're going to make a new one. Now we're going to make a new line. So the x's are going to stay 0 in this case, and the y's are going to be 0.3048 and 0.3048. Okay, so we'll call this vertical test section. Okay, and we create this here. So now we're going to go ahead and look at all of the values on that line. So static pressure, start with that one, vertical test section, call this vertical static. Okay, we save plot. Ooh, that looks a little bit crazy. Oh yeah, so the reason why it looks crazy is because we needed to change this. Okay, now we're going to go ahead and save and plot. And so this is what we're supposed to get. So this looks pretty good. The next thing here is we're going to close this and make a new one. And this one here is going to be the total pressure. Changes to total. Changes to the Y. That's 0, that's 1. And then we'll go ahead and do it along the vertical test section. Total pressure vertical. Okay. Okay, so that's what it looks like here. Oh, whoops. That's static, so this is total. Okay, so now this is what it looks like. Looks pretty good. Next thing here, close this. I'm gonna make a new one. And we're gonna look at dynamic. Dynamic pressure vertical, 1, position at the Y. Looking at dynamic, clicking on vertical, save and plot. Okay, looks good here. We've got the dynamic pressure. Close, and the last one here is going to be the velocity. Vertical velocity, velocity magnitude, 0, 1, vertical, save and plot. Okay, so, oh, that's static pressure. Velocity magnitude. Okay, so this is velocity. Looks pretty good. And, alright. The other thing that they wanted us to see was the streamline patterns. So for the streamline patterns, we're going to do that in the results. So we'll quit this here. Alright, so double click results. It just looks better in the results section, I thought. Okay, so for this, click on do the streamline. Okay, we're going to make a streamline, make this surface symmetry 1. 400 looked pretty okay. Okay, now these are the streamlines. Let's make this 300. You can kind of see the separation a little bit more. If we zoom in, you can see all the streamlines. Okay. All right. That's it for the first part. Now the next part is the bonus part, and so for the bonus part, we're going to click this out. We're going to go on and we're going to draw a little circle in the middle of the test section, and that's why we duplicated the geometry at that point there. Okay, and so we'll click on the sketch here. Alright. So, now what we're going to do here is we're going to make a circle. So, we'll just put it at the origin. Okay, and then we'll make the dimensions. I did 0.1 meters, so that worked okay. So now we have the object here. The next thing here, we're going to have the value. We're going to go ahead and try to center it a little bit more. We'll click on these guys. It's not that one, this one. so we'll just center it like right here or so that it's more in the center of the test section. Okay, so now that we have that, let's go ahead and make our surface. Okay, apply and generate. Alright, and so there's a hole in the middle. That'll be our cylinder. And we're good. So let's move out of this. Going on to the mesh. Alright, we got this here, and it's basically going to be the same type of thing. We'll start off by naming. This is going to be the inlet. This will be the outlet. These will be the walls. Okay, and we'll name this one the cylinder. Alright, so now that we have this here named, we'll start with the mesh method. Geometry selection, select the whole thing. It's going to be the same type of process as before. Okay. Generate. Now we need some sizing changes. Change this to 0.005. And we'll generate. This will take just a few minutes. Alright, just check it out. Looking good. Now we can exit out of this, update. Okay, we're updated. Going on to the setup. And I'm going to try to quickly go through this because we already did most of it. It's all going to be basically the same. Okay, materials, fluids, air. Make this ideal gas, make this Sutherland viscosity, 2 coefficient. Okay. Then we change create, exit out. Okay, boundary conditions, inlet. This is the 10 meter per second one, so make that 10 meters per second. Apply. And reference values, compute from velocity inlet. Surface body. Okay. Now we can initialize and run the calculations real quick. Should converge pretty quickly. Yep, there we go. Alright, now we can look at some of the contours. It says check out the velocity and pressure contours. So we'll start off with this. I'm going to click all of these guys. So this will be the pressure contour. Looks pretty good. Alright, and then next up, we'll look at the velocity. Velocity magnitude, click all of these guys, save and display. Alright, we can see the wake region. This is about what we would expect here. Now, the next thing that they asked to do is get the pressure coefficient distribution. So for that here, first we're going to go to plots, XY plot, pressure, pressure coefficient, cylinder, and can save and plot. Okay, so this is basically, I guess, the line that goes around the circle. Then they want to see the drag and lift coefficients. For that, we go into reference value, or I'm sorry, report definitions, force, look at the drag force first, on the cylinder, compute, okay, we got 13 newtons, drag coefficient. Now, he was saying that Fluent uses the inlet velocity to calculate this, so what you have to do is go into the results, and I'll show that next here. So, what you have to do is you have to go into the results and find the velocity in the test section. So you'll take this value of the drag force and you'll plug it into the equation. But first let's go into the results here and we'll look at the test section velocity. Alright, now first we I think we want to make a velocity contour so that we can have some place to put the probe. Okay, so we have the velocity contour here. Now we want to test for what the velocity is like right around like here in front of the object, so that'll give us a better value for the drag coefficient and the lift coefficient. So we'll put the probe here. We'll see what it is. You look at the velocity, and we get about 25 meters per second, and that's what we would use to plug into the equation. And that about covers it. Thank you for watching.